In this video, we are going to see about type 3 particular integral RHS equal to x power k form where k is positive integer. We can write the pi as pi equal to 1 by f of d into x power k. To solve this, write f of d as 1 plus or minus phi of d by taking the lowest degree term out, usually constant or next to the constant. Pi can be written as 1 by the f of d can be written as 1 plus or minus phi of d into x power k. Then we take the denominator to a numerator and write it as 1 plus or minus phi of d the whole inverse into x power k. We know that 1 plus d the whole inverse equal to 1 minus d plus d square minus d cube plus etc. Plus means here alternate plus or minus. If it is negative means all the terms are positive. That you should remember. 1 plus d whole power minus 2 equal to 1 minus 2d plus 3d square minus 4d cube. Similarly, 1 minus d whole power minus 2 equal to 1 plus 2d plus 3d square plus 4d cube. Then 1 plus d whole power minus 3 equal to 1 minus 3d plus 6d square minus 10d cube plus etc. Similarly, 1 minus d the whole power minus 3 equal to 1 plus 3d plus 6d square plus 10d cube plus etc. Using these formulas, we can extend this term and we are going to multiply by this x power k and we will differentiate the term if necessary. Solve d square minus 1 into y equal to 3x. If you see your right hand side, it is in the form of x. Therefore, it comes under type 3. First, I am going to write auxiliary equation. D can be replaced by m and put right hand side equal to 0. Therefore, m square minus 1 equal to 0. It is look like a square minus b square. A plus b into a minus b equal to 0. From this we can write our roots as minus 1 comma 1. Therefore roots are real and different. Complementary function is c1 e power minus x, c2 e power plus x. Particular integral equal to 1 divided by d square minus 1 into 3x. Here f of d equal to d square minus 1. So this can be written as 1 plus form or 1 minus form. Therefore, I can write this f of d as, by taking minus out, I can write the term as minus of 1 minus d square. Pi equal to 1 divided by minus of 1 minus d square into 3x. Now I can write the term as minus of, this goes to your numerator, and write that as 1 minus d square the whole inverse into 3x. Since it is look like 1 minus d the whole inverse form, so therefore we can write that as 1 plus d square plus etc. So I can write our pi as pi equal to minus of, instead of d we will have here d square. So 1 plus d square, next term plus d square the whole square, next term d square the whole cube plus etc. into 3x. If you see this power of this x, so here the x power is 1, so we have to write constant as well as d power 1. Other than this are negligible. So pi equal to minus of 1 will come. Here it is d square, so d square won't come into 3x. Since higher powers are negligible. Suppose here if you are having square constant d power 1 up to d square, we can extend. Since here x power 1, so we can extend up to only constant because there is no d power 1 term here. So we stop the process. 1 into 3x is 3x. So particular integral is minus 3x. Our general solution is y equal to c1 e power minus x, c2 e power x minus 3x is the required answer. All d square y by dx square minus 5 into dy by dx plus 6y equal to x square plus 3. Now we are going to write this differential equation as first differential operator form. We can rewrite the given equation as d square by dx square minus 5 d by dx plus 6 into y I have taken common equal to x square plus 3. So since we know that d by dx equal to d, we can write this as d square minus 5d plus 6 into y equal to x square plus 3. So this is differential operator form of the given problem. If you see your right hand side, you will have x square plus 3. I already told you whenever you are having constant, it is comes under first type. But in type 3, whenever the constant is involved, we have to consider the entire term as type 3. Auxiliary equation is m square minus 5m plus 6 equal to 0. If you find the factor for this, if you multiply, you should get 6. If you add, you should get minus 5. So therefore, you get m minus 2 into m minus 3 equal to 0 is the factor of the given equation. From this, we can find the roots are m equal to 2 comma 3. Roots are real and distinct. Your complementary function is c1 into e power 2x, c2 e power 3x. Pi equal to 1 divided by, or f of d is d square minus 5d plus 6 into x square plus 3. Here our f of d is d square minus 5d plus 6. This can be written as 1 plus form by taking the lowest degree term out. Here the lowest degree term is 6. There is 6 into d power 0 we can write. So this is your lowest degree term. So if you take 6 out, you will get 1 plus d square minus 5d by 6. Now this is your 1 plus pi of d form. Substitute in that, you will get your pi equal to 1 divided by 6 into 1 plus d square minus 5d by 6 into x square plus 3. Now I will take the term to your numerator and I can write the term as 1 by 6 into 1 plus d square minus 5d by 6 the whole inverse into x square plus 3. So this look like 1 plus d the whole inverse. We can write 1 minus d plus d square minus d cube plus etc. Pi equal to 1 by 6 into, I can extend the term as 1 minus, instead of d we will have d square minus 5d by 6 plus d square minus 5d plus 6d whole square minus etc. into x square plus 3. Maximum power is 2. So therefore we can extend constant d power 1 d square. Other than these terms are negligible. Pi equal to 1 by 6 into, here I can write 1 minus, I can write this term as d square by 6 minus 5d by 6. 1 by 6 the whole square is 1 by 36 into d square the whole square a square minus 2ab plus b square minus etc. into x square plus 3. Since higher powers are negligible, so we can write our pi as 1 by 6 into 1 minus, already told you, constant will come, d will come, d square will come, other than that won't come. So here it is d square, I can write minus d square by 6, minus of minus plus 5d by 6. So next one plus, if we check, this power is 4, so it won't come. Similarly here d square into d cube, it is also won't come. Here d square it will come. So therefore here 1 by 36 into 25 d square into x square plus 3. Now if you want, you can simplify these two by taking LCM as 36. So 1 by 6 into 1 plus, first I will write d term, then I am going to write d square term, that is 25 d square. Here LCM is 36, so therefore we have to multiply this by what? 6 d square into x square plus 3. Pi equal to 1 by 6 into 1 plus 5d by 6. If you simplify this, 19d square by 36 into x square plus 3. Now I am going to multiply this x square plus 3. Here 1 into x square plus 3 is x square plus 3. 5 plus 6 into d of x square plus 3. Here 19 by 36 into d square of x square plus 3. We know that d means differentiation of. Therefore, I can write this pi as pi equal to 1 by 6 into x square plus 3 plus 5 by 6. D means differentiation of. Differentiation of x square is 2x. Differentiation of constant is 0. Next, plus 19 by 36. D square of x square plus 3 means 2 times we have to differentiate this x square plus 3. Differentiation of x square plus 3, if you differentiate once, you will get 2x plus 0 here. If you differentiate it again, you will get differentiation of 2x is 2 is constant, differentiation of x is 1. So therefore 2. Here I can write 2. So finally we can write our pi as 1 by 6 into x square plus 3. Here 2 getting cancelled. We will get 5 by 3. 5 by 3x plus here it will become 18. So we will get 19 by 18. We can write first x square, then x term, that is 5x by 3. Then if you take LCM, so you get 73 by 18. Since the LCM of this term is 73 by 18. Finally, we will conclude our general solution as y equal to complementary function c1 e power 2x plus c2 e power 3x plus particular integral 1 by 6 into x square plus 5x by 3 plus 73 by 18 is the required answer. So you are familiar with your complementary functions. Therefore, directly I will take only pi. Find pi of d square plus 2d into y equal to 24x. If you see your right hand side, it comes under type 3. We can write our particular integral as d square plus 2d into 24x. Here your f of d is d square plus 2d. By taking our lowest degree term, here the lowest degree term is 2d. 2d, if you take it out, you will get 1 here plus here d by 2. This d square will become d by 2. If you multiply, you will get the same as the previous step. Substituting this in pi, you will get 1 divided by 2d into 1 plus d by 2 into 24x. Here this 2 and here it will get cancelled, we will get 12x there. pi equal to 1 by d into, it goes to your numerator and write it as 1 plus d by 2 the whole inverse into 12x. It is in the form of 1 plus d the whole inverse. You will get 1 minus d plus d square minus d cube plus etc. So applying this formula in this, we get the pi as pi equal to 1 by d into, can write 1 minus d by 2 plus d by 2 the whole square minus d by 2 the whole cube plus etc. into 12x. pi equal to 1 by d into 1 minus d by 2 plus d square by 4. Here d cube by 2 cube is 8 plus etc. into 12x. Here the maximum power of x is 1. So therefore we can extend constant and up to d we can extend. So therefore we will get pi equal to 1 by d into constant 1 will come as well as d term will come. Other than that are negligible since higher powers are negligible. So we can write the term as 1 by d into 12x minus 1 by 2 into differentiation of 12x. We can write 1 by d into 12x minus here 2 and this 12. We can cancel 1 2 in that. We can write 6. Differentiation of x is 1. Now we can multiply by this 1 by d. 1 by d means integral of 1 by d of 6 equal to 12. X integration is x square by 2. Constant, if you integrate, you will get simply x. So finally you can cancel these two and write 6x square minus 6x. They're asking only to find pi. So finally we conclude pi equal to 6x square minus 6s is the required pi value.